Okay, so it starts with the midpoint formula. You guys go ahead and find the midpoint of those 2 points because that is just a review. We're doing more of that with today. Oh, and thank you. Thanks for the reminder. Friends who are watching the video or should be watching the video, please write red apple at the top of your notes as proof that you have watched this video. There's your proof. We'll see. Ha ha ha.
I'm gonna be like Todd. I'm gonna like ask a random question in the video class. Like, how can a three-dimensional frequency table be used to this?
I don't even know, guys. All right. Perhaps I should have filmed earlier. No. Okay, who has a midpoint for that first one? Ivan, what you got? That's right. When we find the midpoint, we take the average of the x's and then the average of the y's. And in this case, yeah, they are the same. And then you would end up with, gentlemen, -3, -3. All right, so then, what about number 2? Who's got number 2? Donald?
0.5.
That's right, 0.5 and 1 is correct. So we would add the x values and divide by 2, and then we would add the y values and divide by 2. So today, we just learned about perpendicular and angle bisectors, right? Today we're applying that to triangles, and we're going to give you new vocab terms for them. Okay, last, we got to remember how we label horizontal and vertical lines. Gava, you got that one?
Y=3.
That's right. That is a horizontal line that goes right through the y-axis, so we call that one y=3. What about the next one? That's right. X equals -5. It is a vertical line that goes through the x-axis, so that is x equals -5. Good. So today, you guys, we are going to apply this to some new terminology, and that is your challenge. Again, you're just sorting through vocabulary today. We are going to find the circumcenter and then the incenter of a triangle. So, first word we need to write down is the term concurrent. Anybody know what concurrent means? Trayton?
Alongside, like happening at the same time, like together.
I love that you said that because the geometry definition says when 3 or more lines, rays, or segments intersect at the same point. So happening at the same time when things are concurrent, they are doing that in geometry. It's where they are all kind of merging together. Very good. So concurrent is when 3 or more lines, rays, or segments intersect in the same point. What do you guys think point of a concurrency is called?
Point of concurrency.
Say it again. Kind of.
Point of concurrence.
The point where all of them meet.
Boom. And you guys, I think by saying the middle and what you said, the point of, you guys are, you know what it is, but it's just kind of wording it. I get that.
So the point where where the concurrent
Yep.
lines meet.
So this is the point of intersection of the lines, rays, or segments. Very good. So then that brings us to circumcenter, okay? A circumcenter is kind of a combination of that. So last section, we learned about perpendicular bisectors, right? Now, and that was just with a segment. A triangle has how many segments? 3 segments. So the intersection of all of the perpendicular bisectors is called the circumcenter. So we would say the point of concurrency of the 3 perpendicular PRPND bisectors of a triangle. Okay, so the point of concurrency of the 3 perpendicular bisectors. So they kind of build on each other, right? So then we have, so what I do when geometry is very visual, right? We got to visualize a picture, and I'll draw it on here for our friends who are supposedly listening to this video. Green apple. Oh, red apple. It was red apple. That's right.
Red apple on nose.
I'm going to get them confused. Crap, I did it.
This letter, red apple on nose.
Red apple on...
Remember it was the big red apple on nose?
That's right. Yeah. That's right. Okay. So, guys... So when we have a circumcenter, oh, and there's a picture right here. I don't need to draw it, but you're visualizing 3 perpendicular bisectors and where they meet. And there's a theorem that tells us there is something equal when that happens. So here's our picture, right? We have 3 perpendicular bisectors, and I know they are perpendicular because they're right in the middle. They are not marked perpendicular, but we can assume they are, right? So there's our 3 perpendicular bisectors that are right in the middle. When you have 3 bisectors, the circumcenter means, guys, why are you laughing?
Just Tracy sneezed again. It was so funny. He was so mad. He was like,
Okay, yeah, I get it. Video people, Trayton's got some epic sneezes. There we go. All right, so when you have your circumcenter, the point where they intersect, the theorem tells us the distance from the circumcenter to each of the vertices of the triangle is going to be equal. So when you have a circumcenter, the distance from the circumcenter to each of the vertices of the triangle is equal. That's the special relationship. So you are going to have to go back and look at the theorem and say, okay, what is going to be equal in this case? Okay? So in this next, look at those pictures. They look kind of similar. Is to try to distinguish between the two. You can see this one, see the blue lines? They cross right in the middle. But example, they are going to have you find circumcenters, and all it involves right now is just the slope and the, but in this one you don't even need to use slope. We'll probably have to go through the slope question with your homework when we get to it. But, okay, we want to find the coordinates of the circumcenter of triangle ABC with vertices given. We are going to follow it step by step, and you're going to need to come back to these steps when you do this for homework. So first, let's graph our triangle. So we've got A is at 0, 3. And I like to put the points right on the graph because it just makes it easier. B is 0, -1. And then C is 6, -1. And then we're going to fill it in. We're going to graph it. Holy cow, stop talking. Okay. So now we have to find the midpoints of all the line segments, okay? Sometimes we'll have to use the midpoint, but when it's just a vertical or a horizontal, you really don't need to, right? So if you look at AB, we could totally add the x's, divide by 2, add the y's, divide by 2, but we don't need to. We can just count and see how many units long is that one. How many lines long is that one?
3, 4.
4. It's 4. So what's half of 4?
2.
2. So we would go down 1, 2. And the midpoint would be right there. What point would you say that is?
0, 1.
0, 1.
0, 1.
Yep. 0, 1. That is the midpoint. Okay. What about the lower one? Where do you guys think the middle of that one is? BC, yeah, BC. At 3, yeah, 3, -1, yep. So, like, correct me if I'm wrong, friends, but it's pretty easy to draw a perpendicular line on those, right? So if I drew a line horizontally, that's going to be perpendicular to the vertical. And if I draw a line vertically, like, we can kind of tell where they're going to cross, right? But we can do the math and find it. Let's find the midpoint of AC. Now, that one we're going to have to calculate because it's diagonal. So for that midpoint, I'm just going to add the x's, which is 0 and 6, and divide by 2, and then add the y's and divide by 2 for AC. And then I get 3, 1. And is that where that is? 3, 1? Yeah, that is where that is. Now, guys, I just have to find where all of the midpoints are going to intersect. And it looks like they would intersect right on the midpoint of the hypotenuse. So this one, I don't need to find the perpendicular lines and all that stuff through it. But it might happen where I have to find the perpendicular going through there. So I would just need to go by the slope, right? I can't just draw a line through and have it automatically be perpendicular. If I wanted to find the perpendicular through there, I need to find the slope of that line and then make it perpendicular. So I would go y2 minus y1 over x2 minus x1. So I'd get -1 over 3. So that's the slope of this line. We can test that. We go down 1, 1, 2, 3. Nope. Did I calculate wrong? Y2. Oh gosh, you guys. Nobody told me. Mrs. Lannert. My goodness. A and C, yeah. -1 minus 3. How about that? Y2 minus y1 over x2 minus x1. There we go. That's better. So we get -4 over 6, right? And then if we reduce that, we would get -2 over 3. So 1, 2, 1, 2, 3. Yeah, you can kind of see that. And then if I want to find the perpendicular through it, I would just do the opposite. 3 over 2 would be the perpendicular slope. Thank you. A perpendicular slope of that would be the opposite, right? The opposite reciprocal. So 3 over 2. So if I go to that midpoint, and if I go up 3, right 2, up 3, I can even just do it once, or I can reverse it. Then I can draw that perpendicular. And I just wanted to show you that mainly for other questions. You don't have to really do that for this type of question. But you're going to have other ones on your homework where you got to think about the slope. And I will help you with that tomorrow. But in this case, we didn't really need to do all that because it intersects when you have a right triangle. Bless you, all of the perpendicular bisectors are going to intersect at the midpoint on that hypotenuse. So we would say Draw the perpendicular bisectors. The intersection of these lines is the circumcenter. So our intersection is the midpoint of the hypotenuse. So your goal is just to find the midpoints, draw the perpendicular bisectors. You might need slope if you have a diagonal one. And then wherever they intersect, that's your circumcenter. Does that make sense? Ish. Okay, let's talk about incenter. What other type of bisectors did we learn about last section? What other type of bisectors did we learn about? We talked about perpendicular bisectors. What was the other one?
Converse.
We talked about the converse. Different type of bisector, though.
Angle bisector.
Angle bisectors. Yep. No, he was doing it. Yep, Ivan was doing it. He was. So the angle bisectors are, the incenter is the point of concurrency of the angle bisectors of a triangle. Okay? So the incenter is where all of the angle bisectors intersect. And then it kind of has an opposite but very similar relationship as the circumcenter. So we got to, kind of go back and forth between the two. Oh, got it.
All right, okay.
Good. Okay, so now the theorem tells us when you have an incenter, which is the intersection of all of the angle bisectors, right? It says it's equidistant from the sides of the triangle. It should really say the perpendicular distance. So it's basically you have the incenter and you drop a perpendicular, and those would all be the same. And you can see they look kind of similar. Your job, the other one, they don't cross in the middle, the perpendicular lines. They're just kind of like wherever they're at. Okay? So we would use that to find missing measurements. So in the figure shown, and it tells you it's an incenter, but we know we have an incenter because look at the perpendiculars. Are they in the middle of the triangle?
No.
Nope, they're not. So that means you have an incenter, okay? So the incenter is the intersection of all of those, and then that means the perpendicular distance are all the same. So that means NF, ND, and NE are the same. We also know we have angle bisectors because look at the angles. They're telling us the angles are bisected there. It's telling us they're the same, okay? So they gave us ND. They said ND is 5x minus 1, and NE is 2x plus 11. And they want to know what is NF. What could I do, Deva? That's right. The theorem tells us they're equal, so we're going to set them equal to each other and then solve for x. How would I solve for x? Minus 2x on both sides is right. And then I would add 1. Yup. And then divide by 3, which would give me x equals 4. Okay, now that is x. How would I find the length of NF? Trayton?
You plug it into one of the equations.
Yes, they're all going to be the same, so it does not matter which one.
What's the easier one?
Yeah, I picked this guy over here. Was this your easier one?
You might have to use AI.
No, it... Okay, so what's the length? 19, yep. 19. So NF is equal to 19. Now here's the question. Can NG equal 19? 18, sorry. 18. Can it equal 18? No, why not, Cass?
Because it all has to be equal, and 18 is not equal to 19.
You would be right. That's what they said last hour. However, only the perpendicular distances are equal. So NG is not equal to NF. It's only so the way they worded it in the theorem, it's not good, guys. The theorem shouldn't say all of the distances. It should just say the perpendicular distance. That's the only one that's equal. Geva?
It can equal 18 because it's the hypotenuse. It's supposed to be the longest side of the triangle.
Okay, yeah. I really like what Geva said. Did you see that? See, it's almost like NG makes a little triangle here with NF, right? So NG would be a hypotenuse, and that has to be a longer side. So if this is 19, this can't be 18. That's a great way to look at it. Good job. Yeah, so we would say, no, NG is the hypotenuse
I wish I was hypotenuse.
of triangle NFG and cannot be smaller than an F, which is a leg. So that's one way to look at it. The other way, the book says that the shortest distance between a point and a line is the perpendicular distance. So all the other distances have to be greater than that. Okay? Trayton?
If we were to be explaining that, would we have to like put the whole explanation out, or could we just write no, NG's hypotenuse can't be taller than leg?
That's fine. Just get your point across. It's always better to explain it, but that works with me.